Hello and welcome to the second video on our series on the cash in advance model. In this video, we're going to introduce the cash in advance model in full, and we're going to stop just short of defining the equilibrium and solving it. That's going to be for the next video. This video might be a bit longer than we're used to, so I apologize, but it's better to just keep the whole exposition of the model together. So let's first do an overview of the model, since there are going to be many things that are new. First, we're going to have an economy that works for infinitely many periods. So time doesn't end. It is no longer a two-period economy. Instead, you have an economy where agents live forever. And this is going to require being very careful with our Lagrangian, but otherwise, you're going to see that it's going to look very similar to the two-period economy. The key is that we're going to emphasize what happens between any given period t and the following period t plus 1. In a very similar way to what we did before with periods 1 and 2. Now, production is going to be kept simple. There is no capital, there is only labor, and so we don't need to worry about investment. So the problem of the firm is going to be simplified so that we can focus on the main issue, which is going to be money demand. The government prints money and makes transfers to consumers. We're also simplifying here because we are setting government spending to 0. Because there is no government spending, then we don't have to worry about that portion of the economy for now. Instead, we can just worry about the money supply side that's going to come from the government budget constraint. Now, the key, as I was saying, is that consumers in this economy have a cash in advance constraint. That's the CIA, or cash in advance. And this basically means that they need liquid assets like cash to pay for consumption. So that's going to be the key new feature of this model relative to others. Even more important than the fact that now we have infinitely many periods. You're going to see we're going to be able to control for that. So firms, I'm going to go rather quickly here because we've seen this problem before. Firms produce using only labor. They have a linear technology where ZT is the productivity at some given period T. So this subindex T tells you which period. For example, Y5 is the output in period 5, and Z7 is the productivity in period 7. Firms take as given the nominal prices, PT and WT. This is nominal price of final goods and nominal wage. And they want to maximize the profits every period. So the nice thing here, the nice thing is going to be that the firm's problem is static. So we only need to take it period by period where they are choosing to maximize profits, choosing their labor. Okay, so that seems like a problem we've seen before, and we actually know the solution. The solution is going to be an optimal labor demand. Here I'm already replacing Y for the output function. And we know that the firm's marginal profit per worker, it's going to be PT times ZT minus WT. Critical here, the marginal profit does not depend on the number of workers they hire. And so it's either always positive, always negative, or always 0. If the marginal profit is positive, of course, the firm wants to hire as many workers as possible. They don't see any reason to stop, so they want to hire infinitely many workers. If the marginal profit is negative, remember, it will always be negative, then they don't want to hire any worker. And if the marginal profit is 0, then they don't care. So the firm labor demand is going to be perfectly elastic at a nominal wage of Z times P, or equivalently at a real wage of ZT. And so the wage moves 1 for 1, the real wage moves 1 for 1 every period with the real productivity. And that's all we need to know about our firms. What about the government? Well, as we were saying in the overview, the government here has two functions. They print money and they make transfers or charge taxes. For simplicity, we're going to set G equal to 0 in the slides. So there is no government spending in the model I'm going to show in the slides. The government budget is then very simple. They have the change in the money supply for one period T to the next has to be equal to minus the nominal transfers. So they charge, what they do is they change the money supply, and if they print more money, what they need to do is give it to the consumers. So what they do is they give transfers, and transfers are negative taxes. So all the signs work out. What happens if the government is actually decreasing the money supply? How will they do that? They will charge taxes to people and then they will destroy the money. And so the total money supply will be lower today than it was before because they are just extracting that cash through taxes and then destroying it. So that's kind of like the two things that the government can do. They can print money and then pass it through transfers to consumers, or they can take money out of circulation by charging taxes and then destroying it. Importantly though, the government here is also going to have a monetary rule. So we assume that the behavior of the money supply follows the following rule. It grows at a constant rate of alpha, so that mt plus 1 over mt is equal to 1 plus alpha. So alpha is the actual exogenous variable here. It's the rate at which the money supply is growing. And if alpha is positive, then the government is printing more money, so they have the new money being transferred to households. And as I was saying, if alpha is negative, then that means that the amount of money is decreasing every period. And so money is being taxed away from households and taken out of circulation. And that's going to be our government. So just to recap, the firm and the government side, we're trying to keep simple. Our firm has no capital. They have a perfectly elastic demand for labor. Our government has no government spending, and it follows a monetary rule that characterizes the growth of money by this parameter alpha. Now, what about the consumers? As always, we should be asking, what do they want, what can they choose, and what are they subject to? What can they do? So, what they want is to maximize the present discounted value of their utility. This is similar to when we had the utility in period 1 plus the utility in period 2, and we had our discount factor beta. Now, this is how it looks when you have infinitely many periods. What you're doing is you're taking this period utility that depends on consumption and labor. Labor is bad and consumption is good, hence the minus here. And you're just adding it for every single period, but every period into the future, it's going to be discounted with this factor beta t. Now, what's interesting is that because you discount at a constant factor beta, then the utility between any two periods is always discounted at the same rate beta. The utility between 5 periods, it's going to be discounted at beta to the 5, and so on and so forth. So now we know what they want. Now, what can they choose? Well, they surely can choose labor and consumption for all periods. So this here means that this is a set of all the consumption and labor from t equals 0 to infinity. So this is an infinite sequence of consumption and labor choices. But that's not the only thing they can choose. They can also choose assets to transfer resources across periods. And in this model, we're going to be using 3 types of assets. We have cash, that is MT, nominal bonds, BT, and real bonds, XT. Okay, this is just like in the previous module, nominal bonds and real bonds. All bonds we're going to have in this model are going to be zero coupon bonds. So they buy or sell nominal bonds and the discount price is QT. And then they get paid or they pay their face value next period. So we only have zero coupon bonds here. Remember, we saw in the previous module that if you have a zero coupon bond, you can convert it into a normal bond by relating the price of the zero coupon bond to the nominal interest rate. We're actually going to do that much later in these videos. Now, the same thing happens for real bonds. Oh, and this is a typo, by the way. You can buy and say real bonds. The real bonds price is ST, and then you get paid their face value in the next period. And so consumers are choosing the whole series of variables of cash, nominal bonds, and real bonds from t equals 0 to infinity. And the way we're going to solve that is we're going to take it one step at a time. Basically, every period we're going to be able to analyze separately. More on that in the next video. For now, we should ask the third question, which is what can they do? So this is, look at the budget constraint. This budget constraint looks daunting. It looks kind of long. Let's take it by parts. So let's look at the expenditures. This is similar. We know this. Every period you have the nominal value of your consumption. You can buy bonds that pay in t plus 1. So here the convention is going to be that the subindex of the bonds, it's specifying when they will pay. So today I'm buying a bond at a price Q that is going to pay me tomorrow BT plus 1. So today I buy BT plus 1 bonds at a price QT each that's going to pay me BT plus $1 in the future. Here I'm buying XT plus 1 real bonds at a real price ST that is going to pay me tomorrow XT plus 1 units of consumption goods. Because this is real, I have to multiply by P. I also have to pay taxes, although remember, this T might be negative if you're receiving transfers. So you pay taxes, but this might actually be a negative number. And you save cash. So you also have to save your cash, you have your M. So those are the different sources of expenditure. You spend your money consuming, buying bonds, paying your taxes, or receiving money from the government if it's a transfer, and saving in cash. What about the sources of income? So they have cash that came from period T minus 1. They have, oh, and by the way, there is a typo here. This one went away. I apologize for that. So in this equation, there should be an MT plus 1 here summing. I apologize. So MT is going to be the cash that I saved last period. I have it this period to use. The bonds that I bought last period are going to pay me. Remember, these are zero coupon bonds, so they pay me their face value this period. I have my labor earnings and I have my profits. Okay? All of them nominal. And so this finishes up what's kind of standard for us in the discussion of the budget constraint. What about the cash in advance constraint? That's new. So the cash in advance constraint looks actually very similar to the budget constraint. Let's see what it's made of. So basically it's saying that my total expenditure, net of taxes, has to be equal to my cash on hand. What are the assumptions here? Well, the first assumption is that you have to make all your spending before you get your wages and your profits. Basically, this is a model in which you enter the period, you have to consume, you have to buy bonds, you have to pay taxes, but you only get paid your wages and your profits at the end of the period. Because you only get paid at the end of the period, then you need to have cash in hand in order to pay for your expenditures. Now, there are three things that constitute cash. Literal cash that you just saved from yesterday. This is the cash you saved from yesterday. The bonds that you bought and are paying today. Now, bonds pay at the end of the period, but we're assuming that bonds are liquid because you know that this bond is going to pay you BT dollars at the end of the period. You can just sell it to somebody else for BT dollars. So these are perfectly liquid assets, and so that's why they sum to cash in hand. So to recap, the cash in advance constraint says that in order for you to finance your expenditure, you need to have cash or payments of liquid assets that come from the previous period. Because it's only until the end of the period that you're going to have the payments from your wages. Okay? So that's kind of the key here. The other part is that bonds are like cash because they're perfectly liquid. The problem set has an example where they are not perfectly liquid, and you should take a look at that. Okay, the final thing we need to do, and with this we finish the video, is passing nominal variables to real variables. This is important because the consumer actually cares about real variables. That's the thing they care. That's the thing that goes into the utility function. So we need to make variables real, and it's going to be convenient for us to divide all terms by the exogenously given money supply. So all nominal terms we're going to get relative to the money supply. This might look odd, but it actually allows us to get a sense of how all nominal variables move together with the money supply. So that's going to be interesting. You could have done the same if you divide all terms by PT. So instead of doing what I'm going to do now, you can divide all the terms by PT and you're going to be able to solve the model. Equations are going to look a bit different, but you can do it as well. And so we're going to define the relative money holdings as your M relative to money supply. This real price, real in terms of like it's relative to the total money supply, and the same for relative value of nominal bonds. Okay? Now, what is next? We need to express all the constraints in real terms. And we're almost done. I know this video is a bit longer, but bear with me, this is the last part. So we had our budget constraint. What are we going to do? We're going to take our budget constraint. This is the same budget constraint we have from a slide ago. We're going to divide all terms by m. We're just going to divide all terms by m. So we're going to get all terms relative to the value of money. What's going to happen now? Well, here you get all the nominal variables are now in terms of lowercase m, lowercase b, lowercase p. This happens all over, but we still have some issues because we don't know what bt plus 1 over mt is. We don't know what wt over mt is. We didn't define this variable. We also didn't define mt plus 1 over mt. Let me just be clear about that. What we defined was mt over mts, pt over mts. Here, we instead have mt plus 1 over mts, and that's different. So what can we do? Well, this is what we can do. mt plus 1 over mts, you can multiply it and divide by mt plus 1s. By multiplying and dividing by these variables, you've done nothing, but now you can group the two terms. This first term is just the growth of the money supply. And that we know from the monetary rule of the government. So this first term is 1 plus alpha. And the second term is just little mt plus 1. You can do the same thing for bonds. And so you're also going to get 1 plus alpha, the growth rate of money, times bt plus 1. And then finally, for wages, you can multiply that, divide by p. Then you get the real wage, little w, and the real price, little p. So doing that, you replace and you get the budget constraint. This is important for you to practice going from nominal to real variables. Now the cash in advance constraint, I'm not going to go through all the details because the steps are exactly the same. And then you get a very similar solution to the one above, where of course these first three terms are in common and all these first four terms are in common. So you get the same solution as above by just dividing everything by m. Finally, you get the government's budget constraint. You also have to pass that one to real terms. And remember, the government's budget constraint is the difference in money supply. Here is the nominal transfers or taxes. If you divide everything by m, you're going to get mt plus 1 over m. That's going to be 1 plus alpha. This is going to be a 1. So if you do the math, you're going to get alpha equals to minus pt, this is little pt, times t. So with that, we've finished presenting the model and passing all the equations of the model to real terms. What we're going to do in the next video is get together what the definition of the equilibrium is and how we can solve it.